us switch over to problem number 17. One of the excellent models what we people have got from this particular chapter as such. I read out the problem first. An electric dipole is formed by particles each of mass m having charges minus q and plus q at the ends of a light rigid rod of length L. The system is suspended by a torsionless thread in an electric field of intensity capital E such that the dipole axis is parallel to the field. If it is slightly displaced, the period of its angular motion is how much? In fact, the four options what have been given, let me read out. First option, 1 over 2 pi root under 2 QE by ml. Second option, 2 pi under root ml by QE. Third option, 2 pi under root ml by 2 QE. And fourth option, 1 over 2 pi under root ml by 4 QE. But the correct option for this one is C. That is the third option. But in reality, when you just look at this problem, first and foremost, out of the four options given, two options you can eliminate on the spot without any second thought there. Reason can be understood like this. Time period he is asking. Whenever a body is in simple harmonic motion, maybe in linear simple harmonic motion or in angular simple harmonic motion, whatever be the motion, that is simple harmonic motion of the body, time period general formula is 2 pi under root displacement by acceleration. I repeat, time period is 2 pi under root displacement by acceleration. If it is angular simple harmonic motion of a body, then 2 pi under root angular displacement over angular acceleration. That means in time period, general formula what we have taken up just now, it gives us an idea that time period will be 2 pi under root the value, the fraction in fact, that is acceleration, displacement by acceleration. So here in these four options, two options only have got 2 pi under root some value. So our answer must be either B or C. So first thing, 50% of out of four options, that means two options you can eliminate on the spot. That is, the first option is not going to be correct, fourth option is not going to be correct, forget about these two. The other two we have to pick up. Now see the description what has been given over there and compare that description with the figure what I am drawing here. You are finding two masses over here. This mass is given as m, this also is given as m. The length between these two is given as L. One has minus q charge, other has plus q charge. This particular pair is now constituting an electric dipole. This being the center, we now can say it is suspended with respect to this particular point called center. Now automatically we can understand that particular dipole will now be aligned itself along the direction of the applied electric field on the system. Suppose if electric field is applied horizontally this way, it is going to be along the same direction of electric field there. We can understand that. Now what he is doing, he has just displaced that one with some angle and he has left that one. Then we can all understand straight away that it oscillates simple harmonically. Angular simple harmonic motion that's going to be observed in the case of this particular system now. Now you can understand when it is oscillating that way, it always tries to regain its original direction. It always tries its best to retain its original direction along the direction of the applied electric field. So in this particular concept, a torque that is going to help the system to come back to its normal or original direction, which is along the direction of electric field of intensity capital E that is given in the problem. So I now can write directly the formula for torque. We in fact know what is the torque that is acting on an electric dipole. It is PE sin theta. Out of that, P stands for electric dipole moment. What is this electric dipole moment over here? Charge into the distance of separation between the dipole. What is the distance of separation given here? It is L. So Q into L into E into sin theta, that is going to be the torque that is acting on this electric dipole, which is in fact responsible for this dipole to come back to its original direction of rest along the direction of the applied electric intensity, which is given as capital E in this particular problem. So if you look at the second, according to the concepts of rotational dynamics of a body, torque that is acting on a body in terms of moment of inertia can be written as I alpha. I being moment of inertia, alpha being angular acceleration of that body. But we can all understand here the value of I, which now can be taken m1 r1 square plus m2 r2 square. Since there are two bodies of masses m each, we people have to go for that formula. Out of that, m is common. R is nothing other than the distance from the axis to the mass. What will be this distance over here now? It will be L by 2 on both sides. So we can write directly m into L by 2 whole square. This into 2 I can write because both are equal. So what is it you are going to get? ml square by 4, twice we have to write. So that now becomes ml square by 2 as such. I hope you might have got this point. Ml square by 4 into 2. That now becomes ml square by 2, that is I. Therefore, torque now becomes ml square by 2 into the value of alpha. That alpha itself we have called it as angular acceleration of that system. Fine. Now, according to theory, whether the torque is represented by this or this, torque is responsible for the system to retain its original direction back to normalcy. Therefore, we can equate these two values. Come on, let us equate. What is it we are going to get? We'll be knowing. Q times L into E into sin theta. That now is equal to ml square by 2 times alpha. One cancellation that is possible, L can be cancelled. Fine. But here we have sin theta. We can all understand if theta is very small, then usually sin theta can be written as theta. Therefore, Q E theta is equal to ml by 2 times alpha. But observe carefully, theta is the angular displacement, alpha is angular acceleration. So what will now be the time period? That's what actually is the question. Time period by general formula is 2 pi under root angular displacement by angular acceleration. So what we people can understand from this equation now? What is theta by alpha? You calculate directly. What is theta by alpha? ml by 2qe. This actually is the value of theta by alpha. That only you should write it here. So what is it ultimately? 2 pi under root ml by 2qe. This is the formula for time period of its oscillation. So if you look at this formula and compare with the 4 options given in the problem, this option is exactly tallied with the third option given there. Look at now, 2 pi under root ml by 2qe. That only is given in the third option of that problem. So what is the correct answer over here? The answer for this particular question will now be C, because it is the third option that is tallied with the calculated value over here. But one thing you should understand in this particular model, if a time period is asked, it is 2 pi under root angular displacement by angular acceleration. Suppose if he asks you the frequency of oscillating dipole, frequency of oscillations of the dipole, suppose if they ask you, then it is 1 by 2 pi under root angular acceleration by angular displacement. That means suppose if they ask you the frequency part of it, simply reciprocate this value, this equation. You'll be getting 1 by 2 pi under root 2qe by ml. That is the concept, right? In fact, that is the first option given there. That means that is the formula for frequency. But he is not asking you to calculate frequency in this problem. It is the time period that is being asked there. So the correct answer for this particular problem number 17 is C, according to the calculation what we have made. That is the problem number 17 what we have. Let us work out the next problem, that is problem number 18. An electric field in a large region of Earth's atmosphere is directed vertically down. At an altitude 300 meter, the electric field is 60 volt per meter. At an altitude of 200 meter, the electric field is 100 volt per meter. The net amount of charge contained in the cube of 100 meter edge located between 200 meter and 300 meter altitudes is how much? Now he has given 4 options once again. The first option says 3.54 microcoulomb. Second option is 5.43 microcoulomb. Third option is 300 microcoulomb. And fourth option is given 100 microcoulomb. The correct answer for this one is the first one, that is A, 3.54 microcoulomb as such. First see the description and imagine what exactly the thing he is talking about, because he is imagining a cube of certain side. What is that side length? Everything you can understand if you read the problem carefully. It's a cube means certainly all the sides are going to be equal. That is a concept. So let us consider the data provided to us. An electric field in a large region of Earth's atmosphere is directed vertically down, he said. Direction of electric field, you can take it, it is from top to bottom across the cube. At an altitude 300 meter, electric field is 60 volt per meter. Altitude is 300 meter. Then electric field he gave 60 volt per meter. That's what has been given at an altitude. And of course, while taking up the next one at an altitude of 200 meter, that is a little below that, the electric field is given 100 volt per meter. That's what has been mentioned there. That means simply look at carefully first, 300 meter altitude, 200 meter altitude. That means how much is the gap between these two altitudes now? Exactly 100 meter. The difference between these two is 100 meter. Keep it in mind first. Now read the second sentence there. The net amount of charge contained in the cube of 100 meter edge. 100 meter edge, where it is located? It is located in between 200 meter altitude and 300 meter altitude. That's what he is talking about. So you people should understand straight away, there is a cube like this, which of course has got a side. What is that side value he has mentioned over here? 100 meter side he is talking. Where from it is? This one is 200 meter altitude and this one is 300 meter altitude. In between these two, there is a cube that has been imagined like this, of which the side length is exactly 100 meter as specified in the problem. Now, what is his question? When field is going right across this cube from top to bottom, this is the direction of electric field what has been mentioned there. Then what is going to be the charge that is going to be observed or contained inside the cube? That is the question. So whenever such a model question is asked, immediate necessity for us is that Gauss law. All of us we know E dot ds, that of course is equivalent to Q by epsilon naught. And here across this one means we take that the maximum value of flux. Maximum value of flux, how much it will now be? Simply EDS must be Q by epsilon naught. What is the value of E now? E is to be taken in between these two levels. At one level, at one altitude it is 100. At the other altitude it is 60. Then what will now be this value of E effective? 100 minus 60. Now surface area of one of the sides of the cube, if you take, that surface area is A square. You can now write A being 100, 100 square I can write. Is equal to, charge is to be calculated and epsilon naught value is known to us 8.854 into 10 to the power minus 12 farad per meter. 8.854 into 10 power minus 12. So I am just taking roughly over here 8.85 into 10 power minus 12. Then what will now be the charge over here? It now becomes 40 into 10 to the power 4 into 8.85 into 10 to the power minus 12. Whatever the value you are getting, that will be in coulomb. If you simplify this total lot, you are left with 3.54 microcoulomb. That is the charge. So out of all the four options, look at the very first option please. 3.54 microcoulomb has been given in the first option. So our calculated value is exactly the same as given in the problem in the first option. So we can say now the correct answer for this particular problem is A now. The only thing you should understand here is you have to imagine a cube between these two different altitudes, and the side length is 100 meter, that is given very clearly there. So that is the side, and area of cross section over there in this particular case of one side, that will be taken as L square there, and according to the application of Gauss law you can work out this problem, and it comes to be 3.54 microcoulomb as such. That is the question number 18. So problem 18 is that. Let us switch over to problem number 19, which in fact is a simple problem which is linked with the friction that is acting on a charged body. That linked up model we people have taken up. A sphere carrying a charge 0.01 coulomb is kept at rest without falling down, touching a wall by applying an electric field 100 Newton per coulomb. That means in presence of 100 Newton per coulomb electric field, there is a charged sphere which is in contact with a wall, and the charge on the sphere is given 0.01 coulomb, and it is not falling down. That is the concept. Not falling down means certainly you can understand the body is in equilibrium. So what next? If the coefficient of friction between the sphere and the wall is 0.2, the weight of the sphere is how much? That is the concept officially we have to go for. Weight of the sphere. So here the weight is being compensated by the force of friction that is acting on the charged body. I repeat once again, weight is being compensated by the force of friction acting on the charged body. So what we can write now generally, weight over here is equal to force of friction acting on the charged body. On the charged body. That is the concept you need to understand. So weight actually is mg in general form. But actually force of friction means it is mu times R. What is that R over here? It is the force due to electric field that is acting on the body. So what we should understand, weight now is equivalent to mu, the coefficient of friction, times force experienced by the body due to the electric field. What is electric field value has given you? No. What is mu? That is mentioned as 0.2. The field intensity of the applied electric field that is given as 100 Newton per coulomb into what will be the charge that is on the particular sphere. It's 0.01 coulomb. You better write 10 power minus 2 coulomb as such. So if you look at carefully, these two they get cancelled. Then what is now left over? 0.2 what? Newton. That is going to be the weight of the body. So if you look at all the four options mentioned there, first option is given as a 2 kg. Second option is 2 Newton. Third one is 20 Newton. And fourth one is 0.2 Newton. So obviously our answer is now tallying with the fourth option that has been mentioned there. Therefore, the answer for this particular problem is going to be D. I just will give you a small point here. When a body is in contact with a wall like, usually its weight used to pull the body downward. It is not falling down has been given in the problem. It's not falling down means certainly there should be some opposing force which is equal to the weight of this particular sphere over here, but in opposite direction. What is that force you just have to think of? That is nothing other than the force of friction which is holding that body at that particular position on the wall. What is that force of friction? We know very well it is mu times the normal reaction. In this particular case, normal reaction is nothing other than the force that is acting on the charged body, that is the charged sphere, due to the applied external electric field. That only is the point I just have taken up here. Mu times EQ must be equal to the weight of the body. So weight W is equal to mu into EQ. Simplifying that, you be getting 0.2 Newton, which is the fourth option for us from this problem number 19. So let us work out problem number 20. This problem is a wonderful example for the way or the method these people used to set a problem at JEE level. Their technique is, even though the problem is simpler, they used to make it very lengthy by size. So one should understand every point while reading the problem itself. Reading the problem again and again, one will not find time in the final examination to do it. Thereby, one should read the problem word to word thoroughly. While reading only, you should understand what is the situation that has been described in the problem. See, for example, this model. A disk of radius a by 4 having a uniformly distributed charge 6 coulomb is placed in the xy plane with its center at minus a by 2, 0, 0. They are the coordinates mentioned. So simply speaking, if you look at those coordinates, what can you understand straight away? The center of the disk is placed in such a way that half of its portion is towards the negative x-axis. I once again repeat. The center of the disk is placed in such a way that half of that total disk, that is towards the left of its diameter, it is towards the negative x-axis. And y value 0, z value 0, it is understood that is right at the center. We people can understand that. A rod of length A carrying a uniformly distributed charge 8 coulomb is placed on the x-axis from x is equal to a by 4 to x is equal to 5a by 4. Once again, you should understand, out of the total rod, a by 4 portion is towards left and totally 5a by 4 on the other side of it. It's not right in the middle. Remember that point carefully. 2 point charges minus 7 coulomb and 3 coulomb are placed at a by 4, minus a by 4, 0. X coordinate a by 4, y coordinate minus a by 4, and 0 is z coordinate. Z coordinate is not there because it is placed right in the xy plane. And minus 3a by 4, 3a by 4 and 0. They are the coordinates. Minus 3a by 4, that is x value, 3a by 4, that is y coordinate, and 0, the z coordinate, respectively. Consider a cubical surface formed by 6 faces. X is equal to plus or minus a by 2, y is equal to plus or minus a by 2, z is equal to plus or minus a by 2. Right, that they are the values he has mentioned for the cube. The electric flux through this cubical surface is how much? That is a question. Now see the options what he has given you there. First option is minus 2c by epsilon naught. Second option is 2c by epsilon naught with positive sign. Third option is 10c by epsilon naught. And fourth option is 12c by epsilon naught. The correct answer for this one is A. Right. Now let us see the figure that has been given to it. What has been the figure? If you can understand there, it is over. The problem will be over just like that. What he said, look at carefully. There is a square he has imagined ultimately. This is one face of the cube I am talking about. I am showing you the cross-sectional figure here. This is now its x-axis. This is now its y-axis. And what he said is, there is a disc that is placed here. This is the center. And of course he said, there is a rod that is placed here. How that has been placed, you think of. This length is a by 4 and the remaining length is 5a by 4. That is what has been given. When you consider this one to be the origin, there are 2 point charges which are being placed. 1 point charge comes over here, plus a by 4, minus a by 4 and 0. And what is the other one he has given you? Minus 3a by 4 plus 3a by 4 comma 0. So there are 2 point charges which are given over there. Out of the 2 point charges, this is of minus 7 coulomb, this is of plus 3 coulomb. Now look at carefully, this is the description as given in the problem as such. Now how simple the question is. He is asking you just to calculate the flux that is passing through that, or inside this particular cubical surface. That is in fact a Gaussian surface over here we can take up. What is this phi? That is the concept. We in fact know this one, 1 by epsilon naught times the net charge that is covered well within the clothed surface, which is called Gaussian surface. Now in this particular case, he is giving us very clearly, this has got 6 coulomb charge totally, and this has got 8 coulomb charge totally. Which one? The rod is having 8 coulomb over that one distributed. Likewise, the disc is having 6 coulomb over that particular surface which has been distributed. Now, what will now be this net charge? That is the thing you should identify. Carefully observe. Half of this particular disc is well within the imagined cube. So this charge is to be considered. The remaining charge, the remaining half, is outside the cube. That we don't want it now. So only half of this particular disc is to be considered in terms of its charge. Another. If you look at here, only 1/4 is now covered inside. The remaining is outside, like we people can understand that way. So 1/4 when it is inside, in fact this one must be 3/4, like okay. This now a by 4 means 1/4 of its charge is to be considered. So how much you just look at now? This becomes half of 6 coulomb. Now come back to the next, plus 1/4 of this 8 coulomb. Total is 8. Now it is 1/4. 1/4 of 8. Fine. Now look at the next. Out of these 2 point charges, only one is falling well within the cube. That also -7 coulomb charge is falling inside, positive 3 coulomb charge is outside the cube. So whatever is outside we don't want. Whatever is well within the field we want. So what we should write now? Well within this particular closed surface, it is -7 to be taken as it is. So look at what is this net charge is the concept. Net charge is equal to half of the total charge on the disc, 1/4 of the total charge on the rod, another that charge of that point what has been considered well within that cubical surface, which is -7 coulomb that has been given, that also to be taken. So this in fact goes thrice, this goes twice. Now you are getting here 5 minus 7, that's -2. Then you can directly write this is -2 by epsilon naught coulomb. So how much total charge that we people are having well within that cube which has been imagined there, that comes to be the net charge. That net charge divided by epsilon naught, that now becomes the value of 5. So what can we write in this particular case? -2 by epsilon naught coulomb is the correct answer for this. That is tallied with the very first option given in this problem. Therefore, the answer for this particular problem is A according to the given 4 options there. So simply apply the basic principle of calculating electric flux. Electric flux phi is equal to 1 over epsilon naught times the net charge enclosed in the surface. What is that surface given over here? It is a cubical surface. How much charge that is enclosed inside that? You just identify that one and finalize your answer there. Right? So the answer for this one is A, that is problem number, right? We are having here as 20. That's the point. Check the next number now. That is problem number 21. For the circuit shown, which of the following statements is true? He gave a very simple circuit there, and of course he has given 4 options. Let me first read out the options. With S1 closed, V1 is 15 volt and V2 is 20 volt. Second option says with S3 closed, V1 and V2 both are equal to 25 volt. Third option says with S1 and S2 closed, V1 and V2 they are equal to 0 each. And fourth option says with S1 and S3 closed, V1 will be 30 volt and V2 will be 20 volt. Now if you look at the circuit what has been given there, he has given us 2 capacitors connected with 3 different switches at different positions. Like the very first one, it is now connected over here to earth. Now here there is a switch given. First thing what he has done was that a capacitor is connected across this, like this. Then again he has given one more tap key, the second one. Then of course he has given one more capacitor connected like this, the second capacitor I am talking. And again he has given us another tap key here, which now again is connected to the earth on the other side of it. And he has marked this one as switch 1 and this one as switch 2. Not in an order he has given. Look at that one carefully. Switch 3 is given in between these two. Next one. This C1, it's given 2 picofarad. And of course, we can all understand pico stands for 10 power minus 12. And the corresponding potential difference across the plates is given 30 volt. It's given like that. And what is the potential difference across this one given? It's given 20 volt here like. And what is the corresponding capacity of the second capacitor? That you can see 3 picofarad. So this is the entire system what has been described there. And what is his question there? Out of all the 4 options, which option is correct? In fact, the 4th option is correct. What is that one? When switch S1 and switch S3 both are closed, then V1 will be 30 and V2 will be 20. That means they remain with the same potentials. That is the concept. But you look at how that is correct first of all. If you check first, second, third, you can identify directly they are all not correct. Now 4th one, if you look at, suppose S1 is closed and S3 also is closed. Both S1 and S3 are suppose closed. Then you find C1 and C2 will be in series. That is the point what you should understand. You can write it directly this way. When both S1 and S3 are closed, these two I am talking, both the capacitors are going to be in series. Okay. What is the charge on the first one you see? Is it not C1 V1? That now is going to be 60, right, pico coulomb. What would be the charge on the second one? C2 V2. That is also going to be 60 pico coulomb. But just look at carefully. As such, when I consider the charge on the first one, I am getting 60 picocoulomb, and the charge on the second one, I am getting 60 picocoulomb. And I know when you see S1 and S3 are directly put on or closed, then we are observing that these two are in series. When they are in series, what is the conclusion? Charge on them should be the same. That already we people are finding there. The moment charge is supposed to be equal on these two when they are in series, as such the charges are equal. That means what you can understand there. Whatever is the result we expect, that already is observed here. So again, rearrangement of charge or redistribution of charge is not going to be possible across the capacitors. Again, redistribution of charge is not going to be possible because the total charge when they are in series is supposed to be same across on each capacitor. It is already same. So for that particular concept, for this condition, you should take it for granted that the potential values whatever were existing earlier, the potential differences across the capacitors which were existing earlier, those values will remain as it is. That in the sense what you can understand, when S1 and S3 are closed, then V1 will be 30 volt only and V2 will be 20 volt only. That means therefore V1 must be same as before, V2 also must be same as before. So this particular option, since it is in coincidence with the fourth option that has been given over there, our correct answer for this problem is D as such. So only thing you should understand is when two or more number of capacitors are connected in series, it is the charge that should remain constant and same on all the capacitors. Now the same system is observed over here as well. Thereby potentials will remain as it is or like before. So it must be 30, one must be 20. So total answer for that one is in coincidence with the fourth option that has been provided to us in this problem number 21. So the correct answer for this one is D as such, that is question 21. Let us work out problem number 22, which is based on the concept of a parallel plate capacitor, in between the plates of which three different dielectrics having dielectric constants K1, K2 and K3 are introduced. A parallel plate capacitor of plate area A, plate separation D and capacitance C is filled with three different dielectric materials having dielectric constants K1, K2 and K3 as shown. If a single dielectric material is to be used to have the same capacitance C in this capacitor, then its dielectric constant K is given by. He gave four options. First option, 1 by K is equal to 1 by K1 plus 1 by K2 plus 1 by 2 K3. The second option, 1 by K is equal to 1 by K1 plus K2 plus 1 by 2 K3. Third option, it's given K is equal to K1 K3 by K1 plus K3 plus K1 K2 K3 by K2 plus K3. Fourth option says 1 by K is equal to K1 K2 by K1 plus K2 plus 2 K3. He has given a simple circuit there. It's in fact a parallel plate capacitor, nothing more. But how he has mentioned that one, look at this. This is the parallel plate capacitor. He is talking about the plate area as A. Distance of separation between the plates is given as a D. Now he has made this one into half like this. Half of what? Half of the distance of separation he took. This is now filled with one particular dielectric. Here is one dielectric, here is another dielectric. What are the constants he has mentioned there? You see, this is K1, this is K2, this is K3. So you can understand this is one dielectric, what we have taken. This is the other dielectric, what we have taken. And this is the third dielectric, what we have considered. That is what is the figure given. So first and foremost, if you look at carefully, these two parts, they behave like two separate condensers which are parallel to each other. The total effective capacity of these two is now in series to this particular capacitor. So if I take here, this distance is D by 2. This distance is also D by 2. This value of area is given A by 2. This value of area is given A by 2. So if you can look at carefully, you can get the first capacity of this portion I am talking. It's epsilon naught K1 A by 2 by D by 2. Now second, epsilon naught K2 A by 2 by D by 2. What about this one now? C3 epsilon naught K3 into area is same by d by 2. But look at carefully, this much we need not do. When I say that C1 and C2 are in series, then what will be the effective value of C12? It now becomes epsilon naught A by D into K1 plus K2. And what about C3? We know these two are now in parallel. Sorry, these two are now in series. C1 and C2 are in parallel. That effective capacity is now in series to this. Then how to calculate effective capacity of the entire system? It is C3 into effective of C12 by C3 plus effective of C12. That is official formula to calculate the effective capacity. Now we need not do that much all. You can say when these two are in parallel, what will be the effective dielectric constant of the system? K1 plus K2. When you are just taking up the C3, is it not twice this K3 now? It is 2 epsilon naught A by D into K3. That means what is the other value over there? 2K3. So you can directly understand this way, 1 by effective K must now be equal to 1 by K1 plus K2 plus 1 by 2K3. You can even get the same result by substituting the values here also, but that is not necessary right now. The moment you are observing that its value is becoming 2K3, directly you can estimate that value there. So 1 by K effective is equal to 1 by K1 plus K2 plus 1 by 2K3. Which option is now in coincidence with this one you look at? This is the calculated value. Now 4 options are mentioned. Which option is now in coincidence with this? Second option you look at carefully. 1 by K is equal to 1 by K1 plus K2 plus 1 by 2K3. So what is the correct answer for this particular problem? It is the second one, which is taken as B now. But you can even get that one after just writing this entire calculation also. But it takes a little more time for you. Directly you can estimate after getting what are their individual values. K1 is to be taken alone, K2 will be taken alone, K3 will be taken as 2K3 because epsilon naught A by D into 2K3. So according to that you estimate what will be the effective dielectric constant of that system which can replace all the 3 different dielectrics what are introduced there. So the correct answer for this particular problem is B now. That is the point. Check the next problem, problem 23. Consider a system of 3 charges, Q by 3, Q by 3 and minus 2Q by 3 placed at points A, B and C respectively as shown in the figure. Take O to be the center of radius capital R and angle CAB is given 60 degrees. This question has been asked in 2008 JEE and options are given this way. The electric field at point O is Q by 8 pi epsilon naught R square directed along the negative x-axis. In fact, you people can all understand straight away. When 3 charges circumference are on the top surface of the body, no electric field will be there inside. So A will not be correct. B, the second option, the potential energy of the system is 0. When all the charges are having You can take different distances are there. So potential energy cannot be 0. So second option is not going to be correct one. The magnitude of the force between the charges at C and B is Q square by 54 pi epsilon naught R square. In fact, that is the correct option for us. And the potential at O is Q by 12 pi epsilon naught R. That also is not going to be correct. You can check that one. So what is the figure that has been given to us? Look at carefully first. He is just mentioning that there is a combination of three charges. This is one of the diameters. This one the other diameter what has been given over here. And this is the point called O. This is the figure what has been provided to us. Look at carefully, this is x-axis he has mentioned and this one is mentioned as y-axis over here. In addition, this is the center that's given as O. And he is telling us this point as A, this point as B and this point as C. This angle is given 60 degrees. And of course, as usual, the total radius that is given as R. You can certainly understand that point. It's not a big task. So if you look at carefully, according to the question, at A, he has placed a charge Q by 3. At B also he has placed a charge Q by 3. At C it has been placed as minus 2Q by 3. So three different charges are placed at three different points which are on the circumference of that. And secondly, he is asking you to calculate what is the force that is between this point C and this point B. Because he has given the third option, the magnitude of force between the points or charges at C and B is Q square by 54 pi epsilon naught R square. That's what has been given. So you know very well what is the charge over here, what is the charge over here. But only point you need to know is what is the distance of separation between these two. If you can calculate that one, you can estimate what is the force that is going to exist in between those two charges which are placed one at B and one at C. But see this total geometry first of all. According to the geometry of this figure, this particular triangle becomes an equilateral triangle. So what we can understand here from the figure, triangle AOC is equilateral. That you can identify. The moment it is equilateral triangle, then what can we write? That implies OA, AC, CO. Anything you can write that one as radius. Because you know very well this is radius. This is also radius. Then this automatically should be the radius. There is no other way out. So that is the first identification we need to have from the figure. The moment you have understood that this distance is R, this angle is 60, and for this particular triangle, this now becomes opposite side for this angle. Then what can you write? You can say from triangle, you take this one as A, C, B. What is the value of tan 60 you calculate? Tan 60 is nothing other than CB opposite by CA adjacent. This of course you know very well, CB by CA is R. Already AC we have written it as R. Therefrom I can write that CB must be R tan 60, which now will be r root 3. So this distance now you are getting it as r root 3. That is actually the distance what is needed to calculate the force between these two charges. So what will now be the force between the charges, please? Look at, therefore, force 1 by 4 pi epsilon naught q1 q2 by r square, q1 being 2q by 3, q2 being q by 3 by r square is r root 3 whole square. So you can directly write the same thing this way. It's 1 by 4 pi epsilon naught as it is. This now becomes 2q square by 9 into 1 by 3r square. So this 2 gets cancelled twice. So what is left over? You look at 3 times 2, 6 into 9, 54. So q square by 54 pi epsilon naught r square. That is the force of attraction between these two charges which are being placed, one at C and one at B. So out of all the 4 options given, if you look at carefully, the force existing between the charges placed at B and C is q square by 54 pi epsilon naught r square. So what will now be the answer over here? The answer is the third one, that is C for us, that is problem number 23. Only thing you should understand from the figure is, from the geometry, this is going to be an equilateral triangle. If you can identify that one, automatically you can estimate the distance between the points B and C. That distance is enough for us to calculate the force between the points B and C or the charges placed at those 2 points. 1 by 4 pi epsilon naught q1 q2 by r square formula according to Coulomb's equation. So we can estimate what is the corresponding force between those two. That force certainly will be of attractive nature because one is negative and one other charge is positive. They are opposite charges like, so automatically force of attraction only that exists in between those 2 point charges. So the correct answer for this particular problem number 23 is C. That is the point. 24th problem has been given this way. A 2 microfarad capacitor is charged as shown in the figure. The percentage of its stored energy dissipated after the switch S is turned to position 2. He gave 4 options. First option is 0%, second option 20%, third option 75%, and fourth option 80%. How much energy that has been dissipated is the concept. And what is the circuit he has mentioned? Let me just draw that one over here. There is a cell here of potential difference given as V. And of course, we people are having a small arrangement, a switch arrangement here. And here we have a capacitor like this. And of course, one more switch arrangement here, that is a changeover switch like. And another capacitor that is now connected across this one like this. All the 3 are now connected at the other end. And of course, he is talking about this is the first position of the switch. This is the second position of the switch. So first and second positions he is talking. This is 2 microfarad. This is given 8 microfarad. That is actually the question mentioned. But in my opinion, such model questions, we should not write so many steps for that. Simple observation will certainly make you people get the correct answer there without any sort of a confusion there. What for you just look at first. Suppose when you are just connecting to the first position, certainly this particular capacitor will be charged. What is that value of charge? Means it is QV, you can write. Q is equal to CV, you can write. Q is equal to CV. That also you need not calculate. Look at first, that's all. This is going to be charged first with this cell when it is connected in the position 1. That he also has mentioned in the problem. 2 microfarad capacitor is charged as shown in the figure. Means what? When it's connected to the first position, it is getting charge from the system. That is that cell what has been connected across. Fine. The percentage of its stored energy dissipated after the switch S is turned to second position. This is the switch what he is talking. Now it is to be turned to the second position. Turned to second position means automatically this will be off over here. Whatever charge that it has already gained, that now is to be distributed among these two. So you can certainly understand, suppose charge attained by this one is Q. What will be the ratio of these two capacitors? The capacities of these two capacitors are in the ratio 1:4. Then charge distribution also should be in the same ratio 1:4. Same ratio 1:4 means what you should understand, Q1, which is the charge on this first one, will now become 1/5 of the total charge. 1/5 of total charge means, can't you understand, its charge is now becoming simply 20% of the original value. And half QV square, the formula for energy we all know. The energy is half QV square. When these two are in parallel, V remains constant. So depending on the charge, the dissipation of energy that depends. Depending on the charge, the dissipation of energy that can be estimated and calculated. So earlier its charge was Q. Now it is becoming 1/5. 1/5 means becoming 20%. Then automatically how much it is losing? 80% of charge it is losing. It's giving to the other capacitor. Then how much is going to be the energy dissipated there? Surely 80%. So when this is equivalent to 20%, how much it has lost? That's 80%. So what will now be the energy dissipated? Energy dissipated is now going to be around 80%. So 80%, the correct answer that has been given in that particular problem is coinciding with the fourth option you look at. But look at carefully, 20% also is option there, second option. 20% is remaining with it. How much has gone out? How much has been given to the other? How much it has been dissipated there? That's what we just want. So no need for you to even write all these things. By looking to these two numbers, taking the ratio and taking the ratio of charges, you can estimate what would be the corresponding value there. 80% of the total energy is now going to be dissipated from the system. So that is the concept. So answer for this 24th problem is D as given in the options. That is problem number 24. 25th problem is based on the time constant of an RC circuit. Find the time constant for the given RC circuit in correct order. In fact, he is asking you in microseconds. The four options of course are given. 18, 4, 8 by 9 is first option. 18, 8 by 9, 4 is the second option. 4, 18, 8 by 9, third option. 8 by 9, 18 and 4, the fourth option. So what is the circuit 1 he has given? Look at the very first circuit. He just has given us two resistors are in series like this. This is the first one, the second one. Here, two capacitors are connected in parallel like this. And of course, here is a voltmeter connected like this, and this is given like this. This is the first circuit. And he gave this one as R1, this one as R2, this one as C1, this one as C2. What are the values given? R1 is 1 ohm, R2 is 2 ohm, C1 is 2 microfarad, C2 is 4 microfarad. This is the data provided to us. And if you look at the second circuit, what has been mentioned there? He has given this time two capacitors are now connected in series like this. Then he has connected two resistors in parallel like this. Here is a voltmeter once again, it's now connected across this way. This is a C1, this is C2, this is R1, this is R2. If you simply look at, this is the second circuit what has been mentioned. So both are quite opposite. Here two condensers are in parallel and two resistors are in series. There two resistors are in parallel and two condensers are in series. Now coming to the next one, the third, a voltmeter once again is connected across here, and he has given this time both resistances and capacitors are in parallel like this. He said two resistors are connected in parallel this way and two capacitors are connected in parallel this way. This is the third one. This is again R1, R2, C1, C2. In fact, we all know time constant for any RC circuit is CR. The formula itself is that. Which C to be taken? C effective. Which R to be taken? R effective. So let us take this one first. R1 is 1 ohm given, R2 2 ohm given. C1 is 2 microfarad given, C2 is 4 microfarad given. So for the first one I am calculating. R1 and R2 in series, therefore R effective value will now be 3 ohm. C1 and C2 are in parallel, then C effective value I can write this one as 6 microfarad. In series here we have to add them, and here parallel also we have to add them. So what is going to be the value of tau 1? It is C into R. That is effective C into effective R. So what can we write now? 18 microsecond. That is the first value. That is for the first circuit, the time constant value. That is 18 you have to think of. Now come to the second one here. If you take here, C1 is again given 2 microfarad, C2 is 4 microfarad, R1 is 1 ohm, R2 is 2 ohm. Now you can say these two are in parallel series. Then what would be the effective capacity now? It is 2 into 4 by 2 plus 4, that is 4 by 3 microfarad. C1 C2 by C1 plus C2. Exactly like that, when these two are in parallel, what will now be the effective resistance? It's 1 into 2 by 1 plus 2. It's 2 by 3 ohm. So effective resistance is 2 by 3 ohm, effective capacity is 4 by 3 microfarad. Then what will now be the value of time constant for the second circuit? Second circuit tau 2 is again C into R. C is 4 by 3. This one is 2 by 3. Then what will be the value? 8 by 9 microsecond. That is the time constant in the second circuit as such. Look at the next one now. R1 and R2. These two, R1 is 1 ohm given, R2 is 2 ohm given. Both are in parallel. And C1 is given 2 microfarad here, C2 is given 4 microfarad here, both again are in parallel. When they are in parallel, effective capacity becomes simply 6 microfarad. When these two are in parallel, effective resistance becomes 2 by 3 ohm as such. Then what would be the time constant for this third circuit that I write tau 3? It is again CR. What is effective value of C? 6. What is effective value of R? 2 by 3. This now becomes 4 microsecond as such. Just look at carefully here. For the first circuit it is 18 microsecond. For the second circuit it is 8 by 9 microsecond. And for the third circuit it is 4 microsecond. So 18, 8 by 9 and 4. We want to have this combination there. So which one is the correct combination over here? The answer that is given over here is in coincidence with B. So 18 for the first, 8 by 9 for the second and 4 for the third. The correct option is B for this particular problem. So if you look at this concept of time constant, in fact this comes under transient currents. Out of that, growth and decay like concepts we people used to discuss. CR, whenever we consider growth and decay of charge, we people used to estimate out of that. Under that caption, we people are finding the value of time constant of this CR circuit. So the answers are 18 microsecond, 8 by 9 microsecond and 4 microsecond. The correct answer for this one is B as such. That is problem number 25 for us.